All right, so section 1.1, pre-cal 20, this is question number 1. We're talking about arithmetic sequences, and this question says, identify the arithmetic sequence from the following sequences. Okay? For each arithmetic sequence, state the value of T1, of D, and then do the next 3 terms. So we first have to identify if it's arithmetic. So the arithmetic sequence is one in which the numbers that are listed are separated by the same difference each time. Okay? So let's take a look at the first one. The first sequence is 16, 32, 48, 64, and 80. That's what we're given. Can we tell from this whether this might be arithmetic or not?
Yes.
So it looks like we add 16 to get the next one. Here we add 16. Here we add 16, and here we add 16. Okay, so the common difference is 16. This appears to be arithmetic. Are you good with that?
Yep.
All right. So yes, it's arithmetic. Now, with arithmetic, we also need to state the value of T1 and the value of D and the next 3 terms. So let's do that for A. So T1, what does T1 represent again?
Term 1.
Very good. Term 1. So T1 is? It is. It's 16. It's the first one that's listed. Very good. That's easy. Awesome. Okay, D. Well, we did find D in order to identify whether this is arithmetic. So D is?
16.
Right on. And we could double check that by checking the difference between each successive number. So 32 minus 16, 16. 48 minus 32, 16. And so on. So yeah, the difference is 16. Now, the next 3 terms, how can I use all of this information, what's given, to find the next 3 terms?
By adding.
Adding what?
To 80.
Okay, adding to 80, the common difference. You'll get the next term. Awesome. So the next 3 terms would be 96, 112, and
138.
I think 28 will go. Yeah, 128. Does that look right? I think so. Awesome. So it's arithmetic. Here's your first term. There's your D. There's your next 3. Awesome.
That's how you want us to show our work.
Yeah. So when you do your questions and show your work, I do like your answers circled. Normally, like something like this, if there's calculations, you don't have to circle your calculation. Just circle your answer. If there's a number of answers, I don't need a bunch of circles like this actually. But generally, when you're doing homework with me, show your work, please, and kind of work down if you can, and I will model this throughout the class, but work down and then circle your answer at the bottom. Make sure you have proper units and proper rounding and all that sort of stuff. So this is just all your answers for A. Yep.
Can you have arithmetic sequences that you multiply, or is
Okay.
it just add?
So you cannot have arithmetic sequences that multiply. That's a different kind of sequence which we'll study next. So arithmetic is only adding. Now you can add a negative number, which is like subtracting, but it's only adding or subtracting, not multiplying or dividing. That's a different kind. So this one appears to have a difference of 2 here, and then 4 here, and then 8 here. So definitely, we do not have an arithmetic sequence here because the difference is not common between each of the terms. Does that make sense?
Yep.
So you're right. So this one is multiplied. So you multiply by 2 each time. That's a different kind of sequence which we'll study next. So not arithmetic here. Not arith. All right. Everybody good so far? This is easy peasy. You should make this the whole year? Well, maybe the whole year will be this easy. You never know. Probably not. It'll get harder, don't worry. Okay. Okay, let's do number 2 together. How about if I do the next question in your homework assignment with you? Do you want to do that?
Sounds good.
All right. Let's do it.
6.
How about all of
Gotta
it?
do something.
Okay, write the first 4 terms of each arithmetic sequence for the given values of T1 and D. Okay, this isn't hard either. T1 is the first term. So I'm going to write 5, and then I'm going to write a little comma there. Now, how do I get the second term?
You add.
I add the common difference. Now, I know difference is kind of attached to subtraction, but the difference, remember, is subtracting one term from by the term that's before it. So yes, you do add the common difference to get the next term. Okay, so 5 plus 3 would be 8, And then, what do I do next?
8 plus 3.
8 plus 3. So I'm going to write 11. And then 11 plus 3 is 14. And that's the first 4 terms, right? Okay, so do you guys agree with that? All right. B, we have some negative values. Does that make this automatically harder? No, you might not like negatives or fractions, but all the process is still the same. So -1 is the first one. And then I have to add my common difference. So I add -4, which is like subtracting. So what's the next number that I write down? -5. Wow, you guys are so smart. And then what? -9, right. So we're adding -4 each time. So, and -13. Okay?
Wow.
Everyone like that? Easy peasy. All right. Still easy. Yeah, this could be the same thing you did in grade 9, obviously. This is, yeah.
I mean,
You would have, grade 10 maybe? Yeah, whatever. Yeah, a lot of this would be the same. Okay, now here is an expression for the general term. Here's the expression right here. So this kind of gives you a little bit of a machine or a function to transform the n value into the actual value. So for the sequence defined by t of n equals 3n plus 8, find each indicated term. Now, what term is indicated? I don't think I copied this whole thing down. Let me just give me a second. Okay, so for t of 1, it's really easy. All you do is you put in 1 into the expression there. So if n is 1, then n has to be 1 over here. And we find out that t of 1 is actually 3 plus 8, or 11. Moving on to the second one, b, t of 7 is, and so I'm modeling here what your work should look like. And you might think, I don't have to write all that out. It's going to literally take you 5 seconds, okay? And at each step when you write it out, you are mentally processing that, and that's a way that you can kind of, check your work while you write it out. Because I take the time to write out my work, even though I can do it in my head, because, when it's a really long problem, each time I write it out and I look at it and I see it, I can kind of process to make sure that I'm not missing anything, or I'm kind of doing things right. So it helps you that way. So get into the habit of doing this, just like I'm doing it, and then you'll make fewer mistakes, like guaranteed. Do one little thing at a time. So it's 3 times 7, 21, plus 8. T of 7 is 29. So could you do that in your head? Yeah, probably. But you're training yourself for when the math gets harder. Because in pre-cal 20, it's going to get harder. Pre-cal 30, it's going to get quite a bit harder. Calculus, you guessed it, you're going to have like questions that are a full page long or longer. So you're going to want to show your work, because you're not going to want to make a mistake early on to mess up the whole thing. So that's just the way it goes. All right, t of 14. Well, t of 14 equals 3 times, you guessed it, 14 plus 8. So t of 14. Now, 3 times 14, to do this in your head, you might have different strategies, but I always take the tens first. So 3 times 10 is 30, then 3 times 4 is 12. So 30 plus 12, 42. And you can get good at that too and do a lot of stuff in your head. 42 plus 8 is 50. Okay. So how do you guys feel about that? We could check that by listing all of the terms and see if indeed 29 is the 7th term or 50 is the 14th term, but we probably don't have to do that. Okay. All right. Oh, it's starting to get tricky now. You got to use those minds that you have. Number 4 says, for each arithmetic sequence, determine the values of T1 and D. Okay, state the missing terms of the sequence. So I'll let you just jot that one down, and you might have an idea of how we want to attack that. All right, so what can I figure out first, given what I'm given? What do you think I could figure out first? Difference, right. So where do I find the difference here? What do I do?
You add whatever number to get 23.
Okay, so I want to find the difference between 2 consecutive numbers, which is 19 and 23. So D technically is, remember, T of n minus the term just before it. This is the fancy way of writing that. Or D in this case will be 23 minus the one just before it, 19. Or D is 4. Okay, now that's going to be helpful because in figuring out these unknown values, I can just keep going backwards, and I can now subtract that difference from 19 to get this number, and then subtract the difference again and again. Does that make sense? So 19 minus 4 is going to be 15. 15 minus 4, 11. 11 minus 4, 7. So there I have the rest of the numbers, and I look on my list here, and guess what? The very first one is 7, so T of 1 is 7. And that's what the question asked for. This is what the question asked for. And these are what the question asked for. State the missing terms, T1D. How do you like that? Is that good? Awesome. Awesome. Okay. I can tell this is way too easy for you guys. I apologize. I apologize if I'm insulting your intelligence here. No, you're okay? You don't mind? You're not mad at me? Okay, okay. You're not like completely offended? Like, I wish you'd give me some harder stuff to do. Jeez, this is so baby-like. Okay. All right, I'll work on that. I'll work on that for the future here.
Wait, is it just 4A?
What? No, I don't know. There might be more, but I'm not doing all of them for you. No, I'm just going to giving you a spattering of these questions. Okay. All right. So number 5. Let's take a look at that. So leave some room for the rest of number 4. Number 5 says determine the position of the given term to complete the following statements. This is where it's going to get a little trick here. So we want to know what. I'm going to erase some of this stuff just so I can start from scratch. I want to know what term 170 is. You see that? So 170 is what term? What's the n value? That's what I'm looking for. And so what you want to do is you want to go back to the formula for the nth term, and you want to see what value, what you're given in the question, and see what you can find. Because obviously n is right here, so I don't know what n is, but maybe I could solve for n. All right. Well, let's see. Do I have, T of n. Do I have T of n?
Yes.
Oh, tricky question right off the bat. 170 is the nth term. So T of n actually is 170. I actually have 170 is the value of the nth term. You see that? So T of n is 170. So I'm going to put 170 in this spot in the equation. Do I have T1?
Yes.
Yeah, it's right there in the list. That is -4. Now, n is what I'm trying to find, so I don't have it. So in an equation, if you're left with one unknown value, you can pretty easily rearrange the equation to solve for that value. So that's what we're trying to go for. So I have n is unknown. I'm going to have to put the -1 there. And do I have, or can I figure out what d is?
Yes.
It is 6. Good. Just pick any two numbers, one right after the other, and find out what the difference is. Okay, so I have these ones. So there we go. We're using that formula, and we're going to solve now for the unknown term. So the tricky part is, maybe this is the tricky part, but you have to remember how to solve now. And you have to do, you have to do opposite operations sometimes. If you have something multiplied by n, you have to divide that off. And if you have something added to n, you have to subtract it away. So we have to do opposite operations. Brackets can be a little tricky, so sometimes you want to multiply in to get rid of all the brackets, and sometimes you don't have to. So usually, if it's just two terms, multiply in, because then you can have separate terms, and that's a bit easier. So this is the way I'll do this with you. So -4, you can leave the brackets off or leave them on if you want, I don't care. And this is going to be 6 times n, so that's 6n. And then you have to distribute here, so that's times -1, so or -6. So this is something we learned before in class. Hopefully that makes a little sense to you, but you can distribute this as you multiply. So now we have all separate terms. I'm going to get n by itself, so I'm going to leave this over here. I'm going to either gather these terms first and then bring them over, or just do opposite operations and take them over to the other side right away. So I'll do maybe that. So I'm going to add 4 to both sides, and I'm going to add 6 to both sides. And that is going to eliminate the negative 4 on the right side and eliminate the negative 6 on the right side. So on the left side now, I have 170 plus 4 plus 6, or 180. And then what am I left with over here? 6n. And then one final little baby step to solve for n. I'm going to divide both sides by 6. So n equals what? What is 180 divided by 6? What is it?
30.
30. Very good. N is 30. So n is 30, meaning that 170 is the 30th term. So that's the 30th term. You could also write like this: t of 30 is 170. So if you were to add 6 to 8 and do that a whole bunch more times, in the 30th position of numbers, you should have 170.
Does this say Sam?
Yes, Sam, yeah. So I have up here, this is order of operations. And yeah, and when you're solving for a variable, you want to do the order of operations in opposite order. So bedmass becomes SamDeb. Yeah, SamDeb. So we have a Sam in this classroom. Do we have a Deb? Do we have a Deborah?
No.
Oh, too bad. Okay. Sam and Deb.
Basically, Deborah.
Sam and Deb sitting in a tree. Okay.
Now you just need to get married to Deborah.
Yeah.
This
Yeah, if you get married to a Deborah, please come back and tell me. I will be super happy. I'll be able to tell that story to my students.
Yep.
So like when you get married, I'll be like really old.
I'll be
And
Like,
be
I'm
like-
the reason they got
I'll be like,
like,
I actually had a student named Sam, and he married a girl named Deb.
I'll name my kids Ed.
So I'll be like, I'll tell that joke because it'd be super funny, right?
I knew that happened.
All right, do you want me to do number 6 with you? I don't know.
Yes.
Yeah? Okay. There may be more to number 5, but I'll leave the rest for you. Okay, 6a. Let's do 6a together. It says determine the second and third terms of an arithmetic sequence if. So this is kind of, it's just getting you to look at the same kind of thing from different perspectives now, just so you fully understand, right? If you know something really well, you know it inside and out, right? You know it forwards and backwards. Those are all terms that we use. So if you can understand this, you'll be able to answer questions that are slightly different, but about the same sort of thing. So this one says, give me the second and third terms if you're given the first term and the fourth term. So I'm a picture guy, so I like to draw things out, sketch things. That's part of my work. So I do something like this. I'll go, the first term is 6. That's the first one. And then I don't know the second, and I don't know the third, but the fourth term is 33. So that kind of gives me a visual of what I'm trying to find. And when I see this, I can see, this is what pops out to me, that there has got to be some kind of consistent separation between each of these terms, right? That's the common difference. Okay? So I'm going to stop there. Does anyone want to help me through this now? What would you do here? What jumps out at you? Yep.
I thought you could do like, if you did 33 minus 6, that'd be the difference between them.
Okay.
If you divide that by 2, you'd have the.
Okay.
you'd have the-
So, okay, I think you're on a good track there. If you took the difference between 33 and 6, that would be the difference between the first and fourth term.
Yeah.
And then you'd have to divide that up into sections. Now, you said divide into 2. I have a bit of an issue with that. Okay, you have to do the same thing, but divide it by 3, you think? Okay, does anyone agree with that or have a slightly different, you want to adjust that? Or what do you think, Josh?
I think it's would you divide by 4?
Okay, would you divide it by 4 because there's 4 terms?
Oh,
I
no, there's
thought-
3 sections of it.
Johnny?
You can put everything back into the equation. You get 2x's. You get 2 of
Yeah,
like you could put the first term into 6 into the equation.
Okay,
You could put n maybe as 3
okay.
minus 1.
So you could use the equation, is what you're saying. Okay, that's excellent. That's 2 different ways of doing this. The picture way, so the visual way is what you guys kind of went with because that's maybe the way I started. But you could totally use the equation. So I'm going to do it both ways real quick. So I see there's a D here, there's a D here, and there's a D here. So I think about it like this. 6 plus 3D has to equal 33. That's one way of doing it. Another way of doing it, you could say 33 minus 6 divided by, I need 1, 2, 3. I need to divide it into 3 sections. Divide that by 3. That's another way of doing it. And then we'll use the full formula. So this one here, I would go 3D equals, I'm going to subtract 6 from both sides, 27. D equals 9. Divide both sides by 3. So let's see if 9 as a common difference works. 6 plus 9 is 15. Plus 9 is 24. Plus 9 is, hey, there we go. So that works. Now, the other way that you guys, the first way that you guys suggested, 33 minus 6 is 27. Divided by 3 is going to be the common difference there as well, which we also got this. Now, using the full formula, let's try that. I like that one too. I think that will work great. So the fourth term, okay, if we go the fourth term, right, and then we go t of 1 plus, I'm just going to write this out, d. So if the fourth term is 33, and the first term is 6, I can, okay, so where do I go from here, do you think? Because I don't really know the d, but the n is 4. So I could solve for d, I guess, right?
Yes.
So you could solve for d this way, which is going to turn out to be, subtracting 6 from both sides is 27. And then 4 minus 1, that's equals 3d. Good, look at that. D equals 9. So yes, so you could attack this any different way of those 3 or 4 ways. And you get a difference of 9, which is going to give you now the clue to finding the missing pieces there. Okay, so did one of those ways make sense to you? You could do that on your own, you think, doing one of those ways, either visually, using the formula, dividing the sections. Notice that there's 3 jumps of D. So if you take this whole difference here and divide it by 3, you get each one of the jumps. Okay. All right, so is there a B in 6? Why don't you do B, and I'll write it down on the board here, and then I'll give you a chance to do B. Okay, first term is 8, fourth term is 41. So again, if you want to do 8 and then 2, 3, 41, you could, there's going to be 1, 2, 3 D's, very much the same. So 41 minus 8 divided by 3 should give us our D, right? What's 41 minus 8? That's 33. Divided by 3 is 11, right? So D is 11. And if you add 11 to 8, you should get 19. And then plus 11 is 30. And then plus 11 should match up to 41, and indeed it does. So T of 2 is 19, and T of 3 is 30. Okay, did that one a bit quicker, but does that make sense?
Yeah.
Yes.
You guys liking that? Okay. All right. We got just like 1 more minute of class here, so I'm going to go over this. I'll start this one with you, and then you guys can be responsible for kind of cleaning up the rest. Number 7, this is a graph of an arithmetic sequence. Notice that all the points form a straight line because we are adding the same amount from one value to get the next, so it's a consistent amount we're adding. It's a straight line. Now, so the first 5 terms they're asking, well, the first term, which is n, is 1 here. The first term is 5. The second term, a little tough to tell. Looks like it might be what? Ooh, 5. Yeah, each of these looks like to be 2.5 each square. That's a little tough. So maybe 3. So 5, 3 is maybe 8. Is there anything we can know for sure? Look at this one right here. I know that one for sure. I know that the 6th term is 20 because that's the coordinate that matches up with that point. So if you know the first term is 5 and the 6th term is 20, you could figure out what D is, and you could go from there because it's really tough to tell. So quickly, let's do this. What did I say? Where was I? 20 minus 5. Okay. And how many D's are we adding there, or do we have to figure out 1, 2, 3, 4, 5? 5. So 15
Could the junior
by
boys
5
volleyball team please meet in Mr.
is 3.
Glasgow at the
So,
Bell Junior Boys Volleyball
D is
team,
3.
Mr. Glasgow
So we've got
at the
5, 8, 11, 14, 17, first 5. There we go. Does that make sense? You might not be able to get that right from the graph, but you could use what you do know and figure out. Let's see if those points make sense. The third one is 11. That looks like 11. The fourth one is 14. Yeah, just under 15. And 17 here. Yep.
Are we doing part 2 of the assignment tonight?
Yeah. So let's go back. Let's go back to that.
Yeah, we're doing 7.
Yeah. So what was that number we just did? That was 7. Yeah. Okay, so because the days are off a little bit, guys, you should do part 1 for sure tonight. So do part 1 for sure tonight, and then part 2. There may be another example or 2 I'll have to show you tomorrow. So yeah, so do part 1 for tonight. Whoops, and then we'll clean up part 2 tomorrow.
Was part 2 11 and 17?
Yeah, part 2 is number 11 and 17.